Super quick. It's not a test, it's a quiz. Alright, so E-2, solving inequalities. So our big reminder today before we start is, when do we flip? Only when we divide or multiply, Alicia, both sides. Keyword there is both also. By a what? By a negative. That's going to be really the only big difference, is that in the graphing. Otherwise, this is going to feel really similar to solving equations. And we've already done solving equations. You all are already rock stars at that. So today we're just adding on that extra little tidbit. So get that written down, and then we're going to get started. We have 4 examples today. And then we are just jumping straight into your practice. So you should have plenty of time to get your practice done and check your missing assignments. It's going to be great. All right, so for number 1, we're going to have 2x plus 4 is greater than 8. 2x plus 4 is greater than 8. And we're really just going to solve this like we solve equations. Okay, so I'm going to draw my line down the inequality. I like to do mine line by line because otherwise I can't see my inequality very well. And I like seeing it. Okay, if I'm trying to get x all alone, am I going to undo this 2 first? Or undo this plus 4?
Plus 4.
Good. Adding is the least important. So how would I undo adding 4? Subtract. If we subtract 4 on one side, subtract 4 on the other side. Okay, at this point, do I need to ask myself, should we flip the sign? Are we even multiplying or dividing? No, so we don't even need to think about it. Good. Okay, so we're going to have 2x is greater than 4. 8 minus 4 is 4. X is not by itself yet, so I need to keep solving. How did you know to divide, Christy? Good. When we see that coefficient, that number right with that variable, that means to multiply. So to undo multiplying, we're going to divide. So I'll divide by 2 on one side, and divide by 2 on the other side. On your practice today, you're going to see that division symbol like this with that divide, just to let you know. Normally when we write, we use the fraction line, but with Schoology, it's kind of hard to do that. So we're going to end up with x. And then what's 4 divided by 2? 2. This is the stage where I need to ask myself, should I flip the sign?
No.
No, why not? It's not a negative. We're dividing by a positive, so we don't need to flip that sign. The answer is no. So we're going to keep it greater than. So that's the first part of our answer. Our second part of the answer is graphing that and showing it graphically. So to graph it, we're going to draw a straight line or a number line with arrows on both sides. Why do we need arrows on both sides? It goes on forever and ever and ever. Numbers don't end. Okay, I always do 5 tick marks. That's enough for me to be able to test it out, make sure that I know what I'm doing. I'm going to put 2 in the middle. With positive 2, what's going to come to the right of positive 2? Positive 3. And then positive 4. What goes to the left of 2? 1, 0. Good. All right, is this going to be an open boundary or a closed boundary?
Open.
Open. It does not include, so it's open. So we're going to open by that 2, meaning we're leaving it so you can see the middle. And this is a greater than sign. So which way are numbers greater than 2? The 3 and 4 are bigger, so we're going to go to the right. Remember, there's a couple ways to show your answer here. This is one way. This is kind of how it looks on Schoology. And we want to make sure we have that arrow there saying it doesn't end at 4. It's going to keep going on and on and on in that direction. Any number that is bigger than 2 will work. All right, like I said, we're going to do 4 examples today. I'm going to just do number 2 right next to it because I have enough space there. It's going to take up about the same amount of space as number 1. So if you want to do it next to it, you can, or if you want to go below, that's fine too. This time we have negative 5 is greater than or equal to 3x plus 10. So what do you notice is different about this problem?
We switch with sides.
What switched on what sides? You're so close to saying it. What are we trying to isolate? The variable. And we have that equal to, greater than or equal to. But the variable's on the right side. So am I going to undo the 5, the 3, or the 10? Yeah, we don't want to worry about that 5. We want to get this x by itself. So we're getting rid of the 3, and we're getting rid of the 10. Which one do we want to get rid of first? The 10. And how would we undo adding 10? Subtract. And if I do it to one side, to the other side. At this point, we're just subtracting, so I don't even need to worry about that flipping. If I have 5 negatives, and I do 10 more negatives, negative 15 is greater than or equal to 3x still we want x all alone, so we need to get rid of that 3. And how would we undo a multiplying by 3? Divide. So here's my question at this point. When I see that dividing, that's where in my head I'm thinking, do I need to flip the sign? Am I dividing by a negative? No. Is there a negative that I'm dividing by? With? I'm dividing with a negative, but is the number I'm dividing by a negative? No. So my answer is no, I do not need to flip. So I'm going to keep that greater than or equal to. What's negative 15 divided by 3? Negative 5. And what am I left with on the right side? Just x. Good. So then we're going to graph it. So go ahead and draw your number line. I'm going to throw that boundary in the middle, negative 5. Now with negatives, we have to be really careful. As I count to the right, I'm counting towards 0. So what comes after negative 5 to the right? Negative 4, negative 3, because I'm counting towards 0. On the left side, I'm counting away from 0. Okay, this time are we going to have an open circle or a closed circle? Is it an equal to? Yes. So if it's an equal to, we close it, meaning we shade it in. Now this time we have to think really carefully. We want negative 5 to be greater than the numbers we shade in. So if I want negative 5 to be bigger than the numbers, is negative 5 bigger than negative 6? Or is negative 5 bigger than negative 4? It's bigger than negative 6. So this time we actually shade to the left. So I know some people in my period 1 class were like, well, I learned from so-and-so that I always shade the direction of the sign. If that's you, we don't always want to pay attention to that. That's not always going to be the case. Okay, so we have to be really careful with how we read this. We want -5 to be greater than the numbers we shade. Another way you can think about it is plugging it in. If I plug in -6, does it work? Is -5 greater than -6? Yep. So that's the way we shade. All right, we have 2 more. Number 3. We have -2 times the quantity of, what does quantity of mean again? Parentheses. 4x plus 2 is less than -12. Less than or equal to, sorry. So what's different about number 3 compared to the last 2? What are we going to have to change about our method? Yep, we have those parentheses, and we can't get inside the parentheses without undoing that multiplication. So what property do we use to undo multiplication? We could do division, or we could do the distributive property is usually how we do it. We would do that distributive property, especially if there was another thing we were adding on here. So that's that. Pew, pew. Okay, we're going to use the distributive property a lot next trimester. And when I say a lot, I mean like a lot. So I'm going to do -2 times, what's the first part? 4x. -2 times the second part, 2. You might not need to write that part down. That's okay. I'm just writing it down for people who maybe at this point are like, what? So like I said, we're going to use it a lot next trimester. So what is -2 times 4? -8x plus, what's -2 times 2? -4 is less than or equal to -12. Yes, we are multiplying by negative, but did we multiply both sides? Nope, so it stays the same. All right, at this point, if you want to try and work ahead and see if you got this, you can. All right, so are we going to undo the -8 first or the -4? -4. And how do we undo it adding -4? +4. We do it to one side, do it to the other. So we get -8x is less than or equal to -12 plus 4. -8. We still don't have x completely by itself yet, so we still need to keep solving. How are we going to undo a multiplying by -8? Divide. When I divide both sides, or when I multiply both sides, that's when in my head it's going to go bing, bing, bing. Do you need to flip the inequality? Yes. Be-doo, be-doo, be-doo. What tells me that we need to flip the inequality? When we divide, we have a negative and a negative. So you should have that car alarm going off in your mind. So instead of less than or equal to, before I even do the math, I'm going to flip my inequality. So what's my inequality going to be this time?
Now it's less than or equal to. When we flip it, what will it be?
Greater than or equal to. Now, when we say flip, that only means we're flipping this inequality. We're not flipping anything around on the sides. So on the left side, what will I be left with? What will be there? X. X is still on the left side. On the right side, we're doing -8 divided by -8. 1. And then again, a part of our problem is to solve. On your practice work today, it's going to kind of go every other. One problem is going to look like this. And then the next problem is going to tell you to graph your answer. So you'll get this as like question number 2. This will be your answer. You'll do all this work. Question number 3 will tell you to graph it. And then you'll have to use that drag and drop like we did last week. Okay, so you might need to be clicking back and forth, or you might just need a scratch paper to write down your final answers. So I'm going to put 1 in the middle, because that's what I like to do. What's going to go to the right of 1? 2, 3, good. It's positive, so we're counting up. This time, is it open or closed? Closed. Closed means we shaded in saying it is equal to, so it does work. And in which direction are the numbers greater? 2, 3. So I tried making that darker, that way I can see that that's the side shaded in. Alright, last problem for today, number 4. Guys are crushing this. N minus 5 is greater than 9 plus 3n. So what do we see on this one? There are n's on both sides. We have those variables on both sides. So when we see them on both sides, we need to eliminate one of them. We need to get rid of one. Some people like to have their n's always on the left side. That just is what's comfortable to them. Other people like to just get rid of the smaller one, because then getting rid of the smaller one will tell you that you probably don't have to deal with negatives. Okay, so first off, let's think, how many n's is this when it just says n? 1. Okay, so if you want to sneak a 1 in there, you can. So as a class, what do you guys want to do? Do you want to get your n's on the left side, because we like it on the left, or should we get rid of the 1n so we don't deal with negatives? The 1n? Okay. My other class did not do that, but that's okay. So we're going to get rid of the 1, so how do we get rid of a positive 1? Minus 1n. If we do that on one side, do it on the other. So we have negative 5 is greater than 9 plus, what is 3 minus 1? 2. N. If you want to work ahead of us, you can at this point. Okay, am I going to undo the 2 first or the 9? Good, the 9. The 2 is like the best friend. We want to keep those besties together as long as we can. So we're going to subtract those and the 9. Negative 5 minus 9. Whoa, negative 14. Then how am I going to undo that 2? Divide. Good. When I see division, that's where in my head it's going to go beep, beep, beep. Do you need to flip? You guys are hearing all the crazy sounds in my head today. Do I need to flip the inequality on this one? No. Why? It's not a negative. Good. We're dividing by a positive, so I do not need to flip. So here I'm just thinking, what is negative 14 divided by 2? Is greater than, what is 2 divided by 2? 1. And then 1n is just n. Okay, now if this is hard for you to think about, for me it's hard. I always like having my variables on the left. I would have solved it the other way. That's my choice, but we get the same answer. because we did a negative divided by, well, the big idea of the no negative was when we flip. We don't have to worry about that flip. Another way we can write this, if we get to this answer and we're like, that doesn't quite make sense, we can flip around the whole thing. So I can take this n and put it here, take this -7 and put it here, but what symbol do I want in the middle? A less than. If we flip around, we got to flip that symbol around too. And that might make it easier to graph. If you're like, what the heck just happened, then maybe just don't do it. I'm going to throw that -7 in the middle. What's going to go on the right of -7? -6 and -5 go on the right because I'm going to count up to 0. As I go to the left, I'm going to count away from 0. I want more negatives. So -8, -9. All right, open or closed? Open. And if I looked at this, I would want -7 to be bigger than the numbers I shade in. Or I can look at this and say, I want numbers less than -7. So I'm going to go to the left. I'm going to go more negative. And these are really the same answer. I'm going to show you real quick what we got in my morning class. In my morning class, we did this. I'll go back in a second. We did -3n on both sides, which was fine. But then we had to divide by a -2. So because we divided by a -2, we had to flip our inequality. So on our morning, we had to flip, but we end up with the same answer. Kind of cool, right? So cool. You guys are amazed?